once again, everyone. Today we are going to finish out our little past paper session with some electrolysis. Electrolysis is a very important topic in section E. So let's see how this question is tested. Sodium chloride is a typical salt of sodium metal. A concentrated sodium chloride solution, or brine, can undergo electrolysis when it is used as an electrolyte in an electrolytic cell using inert electrodes. All right, so we have a lot of information here. Let's just underline some important pieces. We were given that this is a concentrated sodium chloride solution. This is very important later down to help us figure out this question. We are also told we are using inert electrodes. Inert means that it is not going to take part in the electrolysis process itself. So define the term electrolysis. So electrolysis is the chemical change occurring when an electric current passes through an electrolyte. So an electrolyte is a conductor. It must be able to conduct a current through it. So usually it's a molten or an aqueous ionic compound. There are usually three components of electrolysis: your electrolyte, a battery, and two electrodes. So an anode as well as a cathode. Part 2, write the half equations, including state symbols, for the reaction that occurs at the anode and cathode during the electrolysis of concentrated sodium chloride solution. During electrolysis, only one cation and one anion is discharged. Discharge means we take the ion and we change it back into an atom or a molecule. It depends on the nature. Metals can be discharged as atoms. They can exist as atoms by themselves. But if we have a non-metal, for example, chlorine, it is discharged as a molecule. Non-metals immediately bond with each other to create molecules. So when we have a solution, it becomes a bit more complex to figure out what anion and what cation is going to be discharged. A solution also contains water. So an aqueous sodium chloride solution contains sodium chloride and water. If you guys break them up into their cations and anions, we actually have 4 in total. So from sodium chloride, we would have the sodium ion, the chloride ion, and from water, we have hydrogen ions and the hydroxide ions. So we have 2 cations, 2 anions. Both of them can't be discharged. It's only one of each. So we have some factors that's going to help us figure out which ion is going to be discharged in preference. There are 3 factors affecting which anion is going to be discharged, and only 1 factor affecting which cation is going to be discharged. So it's a bit more difficult to figure out which negative ion will be discharged. So I have the factors here written on the screen for you guys in order of importance. In a particular situation, only 1 factor is applicable. So starting off at the top, the type of anode, whether it's active or inert, is the most important. If you have an active anode, that is the factor you are considering. All other factors would be irrelevant for that particular question. But our question stated that it is inert. So this is not the factor that we are going to be considering for this question. The second one is the concentration. If we are dealing with a concentrated solution, then this is going to be the factor that we are focusing on. So factor number 3, we are also not going to consider that for this particular question. When you are dealing with a concentrated solution, it means if we have a halogen present, that is going to be discharged. So remember, for concentrated solutions, it is a halide ion that will be preferentially discharged. Let's take a look at our ions. We have the chloride ion, chlorine is a halogen, and the hydroxide ion. Because we are dealing with a concentrated solution, it means chloride is going to be discharged. So we already figured out which anion is going to be discharged, and for which cation is going to be discharged, we are just taking a look at the electrochemical series. So you guys can take a look on the screen. We will have the electrochemical series of cations. The lower your cation is, the easier it is to discharge. We want to use the least amount of energy as possible. So we want to use the ion that will take the least amount of energy. So take a look at the list. Identify sodium, identify hydrogen. Which one is lower? Hydrogen is lower. It would require less energy to be discharged. So the hydrogen is actually going to be discharged at your cathode. So we have now figured out which ions will be discharged in preference. So it means sodium is going to remain behind. The OH- ions will also remain behind inside of your electrolyte. So we need to write our half equations. So at the anode, the chloride ions will be discharged. Remember, when you are discharging something, you are changing it into an atom or molecule. So an easy way, let's start off like this. Cl-, this is aqueous. Now we need to figure out if we are adding or taking away electrons. An easy way to do this is to look at the charge. Our charge is 1-, so we are writing that same value in front of our electrons. If we take away 1 electron, we will end up with a chlorine atom. But chlorine is a nonmetal. It will immediately bond with another chlorine atom to give you a molecule, Cl2, which is a gas. Now the last thing we need to do is to balance it. We have 2 chlorine atoms forming our molecule. So that means we need to have 2 chloride ions, and we also need to update this number in front of the electrons. Your examiners like to see a positive sign in front of your electrons, so we are just going to bring it on the other side, similar to a maths equation. When we carry it across, we are changing the sign. So this is how we end up with 2Cl-. On the other side, we have Cl2 gas plus 2 electrons. So you can rationalize it out like this. For our cathode, it is the hydrogen ions that are being discharged. It's the same procedure. Let's see if we can figure out what our half equations would be. So we have H+. We need to figure out whether we are adding or taking away electrons. Let's look at the charge of a hydrogen ion. We have a +1 charge. So we are adding 1 electron back. So if we add on 1 electron, we will end up with a hydrogen atom. Hydrogen, even though it's on the left-hand side of the periodic table, it is a nonmetal. It cannot exist by itself. It will immediately bond to form a molecule. So this will be a gas. Let's balance it. We have 2 atoms being formed. So we need 2 ions. We also need to update the number in front of the electrons. And remember, your examiners just like to see a positive sign in front of the electrons. We don't need to move it. In this case, it's already positive. So this is your half equation at the cathode. So for most of your ions, you can deduce your half equations. The only one you should learn off is for the hydroxide ion. For every other ion, you can rationalize your half equations just like this. Alright guys, so thanks for joining me for our little question today. I hope you all were able to understand the electrolysis of a concentrated solution. See you all next time.